Hello friends, this is AKHILESH Pandeey and here I am going to start the lecture number 8 of network analysis, and the topic is Thevenin's theorem. So this is the very basic theorem from which we will start, and so here it is, Thevenin's theorem. Now first of all we will understand what the theorem states, and the theorem is actually related to the minimization of the large circuit. Now how we can minimize the large circuit? So if there is any large circuit, means any number of elements will be there, any number of voltage sources will be there, any number of current sources will be there, the entire large circuit can be replaced by, if we have some large circuit with some terminal A, B, okay. So this entire large circuit can be replaced by a single voltage source, that is called VTH, Thevenin equivalent voltage source, and a single resistive element RTH, again AB. So this large circuit contains voltage, so many number of voltage sources, okay, and current of course, and the resistance, any number of resistance it can have, okay. So this entire large circuit can be replaced by a single voltage source, that will be called Thevenin equivalent voltage source, and an element that will be called the Thevenin resistance. Now how we can determine the values of these two, VTH and RTH? Because instead of solving the entire circuit, we will have to solve it simply like this, means VTH, RTH will be given. If we have to find the current through this, some load will be connected, suppose some load is connected here, RL, so we will connect that load here and we can easily find the current through RL by just applying KVL, okay. So this can be done very easily once we replace the entire large circuit with these two elements. So how we can find out the values of VTH and RTH, that is the point. Now just see how we can find the values of VTH and RTH. So there will be three different cases for which we will find the VTH and RTH, and I am starting with the first case, and the case is when there is only independent sources. When there is only independent sources in the circuit. Suppose we have the circuit with only independent sources. So I am taking an example and it will be very easy to understand with the example. So here is the example. Suppose we have some plus minus V1 volt, here will be R1, here will be R2, here will be some current source I1 I am taking, suppose, and again R3, and here is the terminal AB. Okay, this is the terminal AB. Suppose some load is connected here, and across this load we have to find the equivalent Thevenin and voltage and equivalent Thevenin resistance. Across this load we have to find, okay. So the entire circuit, the large circuit, is this one, which we have to replace with these two elements, the above two elements that I have given, VTH and RTH. So our task is to replace the entire circuit with VTH and RTH, and moreover our task is to find the value of VTH and RTH. So the first step, we have to find VTH. How we can find the VTH? So what we have to do, we have to just open it, means RL, across RL we have to find, so we will open it, means we will omit the RL, so it will be open circuit, and we will find the open circuit voltage here. How we can find the open circuit voltage? Very easy it is. We will assume the open circuit voltage here. Here we will, so first step is to find VOC, means open circuit voltage across the desired terminal, means across terminal AB of course. Here we are interested to find the VTH across AB, means across AB we are interested to find the Thevenin equivalent. So we will open that load and we will solve it to find the VOC, and very easily we can find the VOC here. Suppose here we have VOC. In the last class we had discussed nodal analysis, and what we will do, we will ground it at zero potential. It is at VOC, of course. VOC is the potential difference, plus minus if I am considering it. So it will be at VOC. Now at this node, what we can do, we have three different currents there, here, here and here. So we can write down the nodal equation for that node. VOC, of course KCL we will apply. VOC minus V1 upon R1, first current through it. Now this one, okay, this one the current we know very well, I1 it is, so minus I1 we can take because it is outgoing, so incoming current will be of course reverse of that. VOC by R3 next we can find easily, and then it will be equals to 0 according to the KCL and of course KCL. So find VOC. Our task is complete by solving this equation because V1, R1, I1, R3 all will be given in the question. So we can easily find the VOC. Open circuit voltage is has been found in this way. Now we have got the VOC. We have got this result. So that open circuit voltage will be equal to Thevenin voltage. So Thevenin voltage is VOC. So our task is over to find the Thevenin voltage. We have got VTH. Now the task is to find RTH. How we can find the RTH? Okay. So to find the RTH, now the next step is to find the RTH. And how we can find the RTH? To find the RTH, what we have to do, we have to deactivate all the sources. Deactivate all the sources. So here we have used the word deactivate. Deactivate means we have to deactivate this one, we have to deactivate this one. These two sources we have. So how we will deactivate the voltage source and how we will deactivate the current source, that will be the task. Okay. So I am supposing that I have some plus minus 5 volt voltage source. Okay. So we have 5 volt voltage source. We are supplying it. I am telling that switch off it, deactivate it. So how we can switch off it? We will just put do it 0 volt. Of course, this is switch off case. 0 volt it will be. Okay. If there will be 5 volt, there will be voltage across it. Okay. If there will be 0 volt, there will be no voltage across it. Means it will behave like a short circuit. 0 volt means there is no voltage drop. It means it will behave like a short circuit. So for deactivating voltage source, we will have to do what? We will have to short circuit it. So we will short circuit this voltage source. Done. Next, to deactivate this current source. How we will deactivate the current source? So to deactivate the current source, again taking the similar example, 5 ampere I am taking the current source. So switch off it means 5 ampere. Instead of 5 ampere, we will apply 0 ampere. 0 ampere. In any branch, 0 ampere current is flowing. It means in that branch no current is flowing, and no current is flowing means there is a break in a circuit. That's why there is no current. It means 0 ampere current, what it gives the result, it means it will behave like an open circuit. Okay. 0 ampere means no current is flowing. No current flowing means there is a cut, there is a break in the circuit. Break in the circuit means it will behave like an open circuit. So to deactivate the voltage source deactivating will be short circuit. And current source deactivating means open circuit. So we just did short circuited the voltage source. Now the next step is to open circuit the current source. Very easy, we can do open circuit. Now the task is to find the Thevenin resistance. So find the resistance RTH across it. It is very easy to find now the RTH, Thevenin equivalent resistance. Here this branch is opened, it means there will be no significance of this R2. It can be ignored now. Okay, I am ignoring it. Now we have R1 and this R3 in parallel. R1 and this R3 in parallel. So RTH can be given directly. R1 parallel R3. R1 parallel R3, and we can find out the rest result. Okay. So Thevenin resistance we can find in this way. And Thevenin voltage we just discussed. So it is over that if there is only independent sources in the entire circuit, then how we can find the VTH and RTH. Okay. Now I am going to the next case, and that is when there is only dependent source in the circuit. So now the case is when there is only dependent source. So here I am going to start when only dependent source in the circuit. Okay. So here we have, suppose an example, plus minus 2V1 I am considering, and here will be some resistance across which plus minus V1. Again there will be some resistance I am considering R2, again some resistance R3, and finally AB terminal across which we have to find the VTH and RTH. So the first case we have to find the VTH. So to find the VTH, we have not to find the VTH here, because here we have only dependent source. Here is the dependent source. Dependent source means whatever the drop across the resistance R1 will be the source across it. Okay. So what we can see here, we can see that there is no any source actually supply. It is dependent. It means when there will be some current through it and there will be voltage drop, then only the voltage source will appear here. It means it is dependent on the circuit itself. There is no any source which can supply the power, which can give the power. It means overall there is no any voltage source available. It means the Thevenin voltage will be 0. VTH will be 0. So this is the case. The first thing, when only dependent source in the circuit, then we will directly write the result VTH equals to 0. Now what about the RTH? How we can find the RTH? Okay, this is the question. Now similar to the last case, if we will try to find the RTH from here, so what we will have to do, we will have to deactivate the given voltage source. So now the case, deactivate this voltage source. Actually when we will deactivate this voltage source, so the 0 volt will be appear instead of it. Now if we will set it 0, it means we are setting the resistance R1 again 0, and that element is actually not 0, means this will be the contradictory here. So we will not follow that step. We cannot find the Thevenin equivalent by setting it to 0. So what we will do then there is a process to find the Thevenin resistance across it, and what we will do, we will just connect a test voltage across it, test voltage V test across it, which supplies 1 ampere current. We are supposing that a test voltage connected across it will supply 1 ampere current. Now we have the source, we have the current, and now what we will do, we will try to find the value of V test. And how we can find the value of V test? Just by applying the nodal analysis. Very simple. V test, here we will get the V test node, and then after we will write the KCL at that point. And now we can write V test, first the current through this one, so V test minus 2V1 divided by R1, next plus, R1 plus R2, next V test upon R3. We have already discussed the nodal analysis, and you will have to do more and more questions to get the command on this type of questions. Okay, now through this 1 ampere current is coming, so we will take it as -1. Okay, overall it will be equals to 0. V1 will be given in the question, or we can find it by just putting as I1 R1 the current through this. So by manipulating we can get the value of V1 as well in terms of R1 or R2. Okay, V test we can find easily through this equation. Once we will find the value of V test, if we have got the result V test, then after RTH, the Thevenin resistance across it. Suppose instead of V test there will be Thevenin resistance. Okay, so what about the Thevenin resistance? This will be the V test, and the 1 ampere current is going through it. So what we can write? We can write that RTH equals to V test upon the current 1 ampere, of course, because voltage upon the current flowing through it, that will be the resistance. So RTH equals to V test upon 1 ampere. So once we have got the result V test, we can directly equate it to the Thevenin resistance, and we have got the result. Means RTH will be equal to V test. RTH will be equal to V test. That will be the final result. So what we have to do when there is dependent source, we have to set VTH equals to 0 directly without solving anything. Next, what we have to do, we have to apply some test voltage across it, and which will supply the 1 ampere current, so current through the given circuit, and by solving it we will get the result V test, and that V test will be equal to RTH. That's the point. So this is the way to solve the Thevenin's theorem, and to solve the value of, to find the values of Thevenin resistance and Thevenin voltage when there is only dependent sources in the circuit. Now we are coming to the last type of the circuit, and that is the circuit which involves both dependent sources and independent sources. So here is the circuit that contains both dependent and independent sources. And let's check out how we can solve the Thevenin theorem for that. Okay, both dependent sources and independent sources. Independent sources. Okay. So let's take an example. So plus minus V1, this is independent source. R1 we have, and suppose through it there is a current I1, and plus minus 2I1, and some resistance, suppose here it is R2, and R3 I am taking, and after that there is some load resistance across which we have to find the Thevenin result. This is AB terminal across which we have to find the Thevenin equivalent VTH and RTH. So again, for this circuit, what we will do for this circuit, we will the first task will be to find the VTH. And how we will find the VTH? Again, we will remove it. We will remove this load and find the value of VOC, the process that we have discussed in the first type. VOC, simply we will apply the nodal analysis here, means we will ground it, and then after VOC will appear here at this point, and we will apply the KCL equation at this node, and we can very easily get the result of VOC. So VTH we can get by VTH setting VOC. Next, the second step will be, why this will be not equals to 0, because here we have some source inside it, in the circuit. So that source will definitely appear, some voltage definitely appear here, because some source is there in the circuit. Okay, so VTH will be given by VOC. Next, to find the RTH. Now, to find the RTH, we will not go in that process by applying V test 1 ampere. No. Instead, what we will do, we will short circuit this terminal. We will short circuit this terminal and try to find the ISC. So our target will be to find the ISC. We can find out very easily. Once we will short circuit it, this R3 will disappear, because all the entire current will go through it. Entire current will pass through it, because there is a resistance and there is no any resistance. So entire current will pass through it. So it will be omitted. Now we have ISC here, and so applying the KCL again, and or we can apply the mass equation, or by solving in any way that we have studied till now, KCL, KVL, whatever will be useful according as per the circuit. We will try to find out the ISC. Our final task will be to find the ISC. Once we will get the ISC, what we will do, we will directly apply this equation VOC divided upon ISC. This will give the Thevenin resistance. So when there is dependent and independent sources both, first we will find the open circuit voltage, and next we will find the short circuit voltage. But by just dividing VOC upon ISC, we will get the Thevenin resistance. So this is the three types of circuits that we will have: independent, only dependent, and both dependent and independent sources. So we will go through this approach to find out the equivalent Thevenin voltage and equivalent Thevenin resistance. So these are the best approach to solve the Thevenin voltage and resistance. There may be so many other approaches as well, but that will be complicated way, and I have found these ways very simple and easy to understand. So you have to follow this way only. Okay, now I am going to solve one question, one previous year GATE exam question related to Thevenin's theorem. So here is the question, and the question has been asked. Actually, there is no any tag with this question, but it has been asked in the previous GATE exam. I am very sure about it. So the question circuit is here, plus minus 0.5 I1 and 1 ampere current source is here, 5 ohm resistance is across it, AB is the terminal here, and here it is again we have 5 ohm, and finally what is there? There is a voltage source of 10 volt. Okay, so this is the question, and what we have to find for the circuit on Thevenin voltage and resistance. Voltage and resistance across AB. Across AB. Terminal is terminal is, options are 5 volt and 2 ohm. The second option is 7.5 volt and 2.5 ohm. The third option is 4 volt and 2 ohm, and the last one is 3 volt and 2.5 ohm. So this is the question that we have, and we have to solve it to find the Thevenin voltage across it and Thevenin resistance across it. So here we can see that there is a dependent source, and there is also independent sources here. So this is a mixed type, independent and dependent both. So the first task is to find the VOC across it. Open circuit, already open circuited here. Now to find the open circuit here, VOC. Okay, so to find the VOC, what we will do, we can omit this question because we can have the space here very easily. So VOC, we can find VOC divided by 5 ohm, of course we are not taking the unit, VOC by 5, setting it ground, and next minus 1 plus VOC minus 10 upon 5 equals to 0. By solving it, what we will get, VOC 2 VOC by 5, 2 VOC by 5 equals to 3, and VOC, of course, we will get 15 upon 2. So this is the result of VOC. The next result is to find out ISC. The last case, ISC. Okay, so we are short circuiting it. ISC we have to find. So when we will short circuit it, there will be no use of it because all the entire current will go through it. Now here ISC, here 1 ampere. So through this branch, what will be the current through this branch? Okay, so we can easily find it. This will be the 1 ampere, this will be ISC. So here we will have 1 minus ISC. 1 minus ISC will go through this branch. Okay, now we will apply the KCL in this equation, this loop. So 10 plus 5, 1 minus ISC, and equal to 0, of course, equal to 0. By solving it, we will get the result, and what will be the result actually? 2 and 10 upon 5, 2, and 2 minus 1, 2 plus 1, of course, this will be the 3. Okay, so we have got the ISC as 3 and VOC equals to 15 by 2, or you can say 7.5 volt. So RTH will be VOC upon ISC, and VOC is 7.5 divided by 3, so we will get the 2.5 volt. And this was the option number B, as 7.5 volt and 2.5 volt. So this is the correct answer, and we can get it very easily, and this question has been asked in the previous GATE exam. So in the coming exam this type of questions can be asked, and apart from it as well, this topic, Thevenin equivalent voltage and resistance, are very useful in the application part of the coming chapters. So you must have to do practice this type of questions from your standard textbooks, or from the previous GATE exam, or from previous ES exam. So to prepare accordingly, and if you have some doubts related to the Thevenin theorem, you can put it in the comment box. I will definitely try to reply that. Thank you so much for watching. In the coming days I will upload some more videos related to the network analysis. Thank you.